Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In exams like NEET and JEE, the model of river boat, which comes under the concept of relative velocity, is an important one. Several times questions on river boat is asked. It is also interesting to solve problems like this in physics. Let us see that in this video. So what if there is a river of some width and there is water current? So water is flowing at some speed. Before talking about a boat trying to cross the river, move from one bank to the opposite bank, let us talk about two important terms, that is downstream and upstream. So what is downstream? Say this is the velocity of the river, and velocity of the boat with respect to river is also in the same direction. This is known as downstream. It is like an escalator which is moving up. You're on the escalator, and with respect to escalator, you're again moving up. You're trying to go up. So obviously, in this case, velocity of the boat with respect to river is velocity of the boat minus velocity of the river. So velocity of the boat is equal to velocity of the boat with respect to river plus velocity of the river. So this is the equation we generally use. For any riverboat problem, velocity of the boat as seen from the ground is what we need. We know the relative velocity. Relative velocity VBR is the capacity of the boat to move inside the river. VBR. Or for example, you are standing on an escalator, and on escalator you are trying to move like 1 step per second. You're going up at the rate of 1 step per second. An escalator is going up at the rate of 2 steps per second. And with respect to escalator, you are going up again at the rate of 1 step per second. So what is the speed of you as observed by some person who is standing on the ground? It will be 1 plus 2, isn't it? Because escalator is already taking you 2 steps in 1 second, and you are going at the rate of 1 step per second with respect to elevator or the escalator. This 1 step per second is your capacity to climb up the steps on an escalator. Similarly, velocity of the boat with respect to river, say if it is 5 km per hour, it is the capacity of the boat to move inside the river no matter the river is still or flowing. So if the river is flowing towards right and velocity of the boat with respect to river is also right, we call it as downstream. In that case, as seen by the ground, velocity of the boat with respect to river and velocity of the river both are added, and so you can find out the time in which the boat covers a certain distance, say certain distance s, that is equal to VB into T. So time would be equal to S by VBR plus VR. Now what about upstream? Upstream is velocity of the river is this way, and velocity of the boat with respect to river is opposite. The boat is going against the stream of the river. It is going against the current of the river. In that case, it's like escalator is going up at the rate of 2 steps per second, and you are getting down the escalator at the rate of 1 step per second or 3 steps per second. It can be anything. So velocity of the boat, again I can use this equation, velocity of the boat is equal to velocity of the boat with respect to river plus velocity of the river. So velocity of the boat with respect to river is minus VBR I cap, and velocity of the river is VR I cap. So this is VR minus VBR I cap. This is velocity of the boat. Same thing if you apply here, you get VBR plus VR in the case of downstream. In the case of upstream, velocity of the boat as seen from the ground is velocity of the river minus velocity of the boat with respect to river. Or escalator is taking you up at the rate of 2 steps per second, and you are getting down with respect to escalator at the rate of 1 step per second, what is the velocity as observed by some person on the ground, standing on the ground? It will be like 2 minus 1, that is 1 step per second. On the whole, you are only coming down at the rate of 1 step per second, because escalator is bringing you 2 steps down. At the same time, you are going up by 1 step. So the effect is 1 step per second down. So this is upstream. Suppose in upstream, the boat has traveled a distance of s, then velocity of the boat into time. So the time taken to travel a distance s in case of upstream would be same the distance s by VR minus VBR. So it takes less time in downstream, obviously, because both speeds are added up. It takes more time in upstream because the boat is going against the flow of the river. These are two simple concepts of downstream and upstream. It's very simple. Now comes the concept of a boat crossing the river from one bank to the opposite bank. Now, let me say the velocity of the river is VR, so I'll write VR bar. Velocity of the river is VR I cap. Now the boat wants to cross the river. Say the initial point of the boat is point A, the right opposite point is B. Now observe here, if the boat tries to cross the river by heading perpendicular to the flow, then it will never reach point B, because boat wants to move up and the river is drifting the boat towards right. So the resultant movement of the boat is in this direction. Boat wants to move up, the river is drifting, the boat is actually moving this way. Boat wants to move up, river is drifting, boat is actually moving this way. If the boat heads perpendicular to the flow, aiming at the right opposite point, it will never reach the right opposite point, because of the simple reason that the river is drifting the boat horizontally. Now, what if the boat has to reach the point B, which is right opposite to A? There are two things in this problem. What is the shortest time that a boat can take to cross the river, given the boat's capacity to move inside the river? What is the shortest possible time? And what is the shortest possible path that the boat can take? Don't you think the shortest path is simply AB? Because say the river, say D meters wide, the shortest possible path to cross the river is AB. But the challenge is, if the boat heads along AB, it will not reach B. In order to reach B, boat has to head at some angle theta. So let me say this is theta. This is velocity of the boat with respect to river. Suppose velocity of the boat with respect to river is 5 km per hour. If this is given, it means it is the capacity of the boat to move inside the water, no matter the water is flowing or the water is still. The very first statement of the question related to riverboat problem will be like this: a boat can move at the rate of 5 km per hour in still water. So if that statement is given, it means that velocity of the boat with respect to river is 5 km per hour, even if the water is flowing. Because if the water is still, velocity of the boat is equal to velocity of the boat with respect to water. So what is given in the question is the capacity of the boat to move inside the water, whether the water is still or moving. If the water is moving, so the person will head in some direction, the river is drifting in. All over, if you observe from the ground, boat is taking a different path. So how do I do that? Now I can write velocity of the boat with respect to river vector. So I can resolve this. If I resolve along horizontal, it is VBR cos theta. Sorry, along the vertical, and along horizontal, it is the component along the horizontal is VBR sin theta. So VBR vector is minus VBR sin theta I cap plus VBR cos theta j cap. In this problem, we know the relative velocity and we are trying to find the absolute velocity, kind of absolute velocity. In the sense, velocity of the boat as seen from the ground. So velocity of the boat with respect to river is velocity of the boat minus velocity of the river. That implies velocity of the boat is velocity of the boat with respect to river plus velocity of the river. This is the equation. So be it downstream, upstream or crossing the river, the equation is this. We need velocity of the boat as seen from the ground. So that will tell us how exactly which path the boat is taking. So if the boat is making an angle theta to the left of the vertical, then there is a chance of boat reaching point B directly by taking the shortest path. So the person is aiming to reach point C. He will reach somewhere here, say point D. So this CD, this is known as the horizontal drift, which is X. The horizontal displacement or the horizontal drift of the person, not this. Yeah. So this is the horizontal drift X. He is aiming it in some direction. But because the boat is drifting, he is reaching some point D. BD is the horizontal displacement of the boat, and AB, that is D, is the vertical displacement. So the total distance traveled by the boat will be root over D square plus X square by Pythagoras theorem. Now there is a possibility of X being 0. How? So we can do this. What is velocity of the boat as seen from the ground? Simply add these two vectors. If you add these two vectors, I have VR minus VBR sine theta I cap plus VBR cos theta j cap. As seen by ground, this is a vector. It means as seen by the ground, the boat has got a horizontal component of VR minus VBR cos theta and vertical component of VBR sine theta, vertical component of VBR cos theta. So this is the result. He is making an angle alpha with the vertical. So this is how a person who is standing on the ground will observe boat. Boat is actually making an angle alpha with the vertical. So what is the speed of the boat as observed by a man who is on the ground? Is root over VR minus VBR sine theta whole square plus VBR cos theta whole square. And what is the tan alpha? Angle that the boat is making with the vertical. So tan alpha is VR minus VBR sine theta by VBR cos theta. This is the angle. Yeah. Now what is the time taken by the person? So I am doing it here. What is the time taken by the boat to reach the opposite bank? So this is the horizontal velocity of the boat. This is the vertical velocity of the boat. With VBR cos theta vertical velocity, he is covering a vertical displacement of D. Whereas with this horizontal velocity of VR minus VBR sine theta, he is covering a horizontal drift of X. So the equation is simple. So vertical displacement D is equal to vertical velocity VR cos theta into VBR cos theta into time t. So vertical displacement is vertical velocity into time. So time is d by VBR cos theta. So this is the time taken by the person to reach the opposite bank. Similarly, what is the horizontal drift? Horizontal drift is horizontal velocity, that is VR minus VBR sine theta into t. So we know the time t. So x is VR minus VBR sine theta into d by VBR cos theta. So this is the horizontal drift of the boat. Now, what is the shortest time that the person can take to cross the river? So for shortest time, so all are fixed. VBR is fixed, it is his capacity. VR is fixed, it is the water current. All he can do is change his angle with respect to the water. For different angles, he is able to reach the opposite bank in different times. What is T minimum? From the equation there, T minimum is d by VBR, minimum value of cos theta. What is the minimum value of, so maximum value of cos theta, because cos theta is in the denominator. We are trying to find the minimum value of T. So T is minimum when the denominator is maximum. The maximum value of cos theta is 1. When cos theta is 1, that is when theta is equal to 0. Cos theta is 1, theta is equal to 0. So the minimum time is d by VBR. The angle with which he should head is 0 degrees with the vertical. A very interesting thing that you can notice here, if he has to cross the river in the shortest possible time, all he has to do is head perpendicular to the flow or head along the vertical. Flow is along the horizontal, head perpendicular to the flow. That is the meaning of theta is 0. So he will not reach B, he will reach some other point D. There is horizontal drift. The distance is not shortest, but the time is shortest. If the distance has to be shortest, so for shortest, so this is the equation for shortest time. So I'll say shortest time for shortest time. So T minimum we just derived, that is d by VBR when cos theta is 0, sorry, cos theta is 1, that is theta is 0, and the shortest distance, for shortest distance, if the person has to cross the river by traveling in the shortest path, so theta should be such that he is directly reaching B, which means x is 0. This x value, the drift is 0, or the horizontal velocity VR minus VBR sin theta must be 0. Obviously, velocity of the boat as seen from the ground should be straight along the vertical. The horizontal component must be 0. So applying any logic, either horizontal component is 0 or the horizontal drift is 0. What we get is VR minus VBR sin theta is 0. So I'm writing VR minus VBR sin theta is 0, or VR is equal to VBR sin theta. So theta is sine inverse VR by VBR. So what does it mean? VR is equal to VBR sin theta. So observe here, VR is in the rightward direction, VBR sin theta is in the opposite direction. If VBR sin theta matches VR, then there is no relative horizontal displacement, because river is taking say 1 meter right and the boat is moving 1 meter left. There is no relative or the resultant horizontal displacement. So the person goes straight to the point B. So it is like the escalator is moving up at the rate of 2 steps per second. With respect to escalator, you are coming down by 2 steps per second. So you will always be there with respect to a person who is standing on the ground. So same logic I am applying here. If VBR sin theta is equal to VR, then resultant horizontal displacement or horizontal velocity is 0. So the person goes to point B. But in this case, it will be shortest distance but not shortest time. If he wants to move in the shortest time, he has to compromise on the distance. If he has to cover the shortest distance, then he has to compromise on time. Because when theta is sine inverse VR by VBR, then the time is also different. So time would be d by VBR cos theta. Cos theta can be written as 1 minus sine square theta, and you have to substitute this value here. So if you substitute this value d by VBR into 1 minus sine square theta, that is VR square by VBR whole square. So the time would be d by root over VBR square minus VR square. This is the time. If the person has to cross the river by covering the shortest distance, he has to compromise on time. The time will be d by root over VBR square minus VR square. And obviously VBR must be greater than VR. Only then there is a valid theta, because sin theta is less than 1. His velocity with respect to river should be more than velocity of the river. Only then a fraction of, when you multiply with sin theta, which is the fraction, this can be equal to VR. So this is for the shortest distance, and for shortest time, theta is 0. He should not bother about anything, head straight, he'll reach some point somewhere. there is always the horizontal drift in that case. You can find out the horizontal drift. So substitute theta 0, sine 0, it is 0, cos 0, it is 1. So it is VR into d by VBR. So x will be equal to VR into d by VBR. Yeah, this is the case of the drift in case of the shortest time. Now let us solve a simple question. This is IIT JEE 1988 problem. A boat which has a speed of 5 km per hour in still water. As I mentioned, when this phrase is given, understand that velocity of the boat with respect to water, magnitude is given by 5 km per hour. It crosses a river of width 1 km. The width of the river D is equal to 1 km in the shortest possible path. So if he has to go in the shortest possible path, definitely he has to maintain the direction of velocity with respect to river. It's some angle theta with the vertical in 15 minutes. It is given the time taken is 15 minutes. The velocity of the river water is. So it is again a simple question. So let me say this is velocity of the boat with respect to river. Resolve in two directions. So we have VBR sine theta, VBR cos theta, and I have velocity of river. He is reaching or crossing a river in the shortest possible path. If he is crossing in the river in the shortest possible path, VBR must be equal to VR, so that there is no resultant horizontal displacement. He is going straight as observed from the ground. So what is the first equation I can write? VR is equal to VBR sine theta. This is the first equation. And he is covering or he is crossing the river in 15 minutes. So vertical displacement is 1 km is equal to vertical velocity, that is VBR cos theta, into time, that is 15 minutes, which is 1/4 of an hour. Because everything I am getting in terms of kilometers and hour, and the speed is kilometer per hour. So 15 minutes is 1/4 of an hour. So let 1/4. So I'll write VBR cos theta is equal to 4. This is the second equation. So, and VBR is also given. I have to find VR. So square this second equation and first equation. So you will get VBR square sine square theta plus VBR square cos square theta, that is equal to VR square plus 4 square. The reason I squared is because I have VBR cos theta and VBR sin theta. When I square and add, square first equation and second equation and add, I can get rid of theta because sin square theta plus cos square theta is 1. So VBR square is equal to VR square plus 16. So VR square is equal to VBR square. VBR is 5 square 25 minus 16, so which is 9. So VR square is 9. So velocity of the river is 3 km per hour. As simple as this, if you understand the concept. So this is all about river boat problem. It is a little challenging, but take some time to understand and do some more examples on this, and your concept will be clear. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.